Okay, let's follow up on making ions out of atoms by gaining and losing electrons. So have a look at the periodic table. So metals are losers of electrons, as we mentioned before. And so therefore on the periodic table, we can always pick out the metal and then move to the previous noble gas to get the electron configuration of the ion. So metals will always lose electrons so that they have the electron configuration of the previous noble gas on the periodic table. So nonmetals will do the opposite. They'll gain electrons and they will get the electron configuration of the next noble gas. Remember, noble gases are ones which have conformed to the octet rule with 8 electrons in their outermost energy level, a filled outer energy level. All right, so this is a graphic out of the book, and it's got a couple problems with it. The cross pieces are missing from some of these plus signs, so just bear with. So five examples of things that happen here: sodium, magnesium, and aluminum. So here's the electron configuration of sodium ion, neon core 3s1. This one electron will be lost and give us just the neon. So the sodium ion plus 1 will be the same as neon's electron configuration. Magnesium 2 plus, again, remember the plus sign's missing there. These 2 electrons are the 2 that are lost to give us again the neon electron configuration. And then finally aluminum, 3 electrons here are lost. It's the 2s 2 electrons and the 2p1 electron, giving us again the neon configuration. So by losing 1, 2, and 3, sodium, magnesium, and aluminum, when they become ions, have electron configurations the same as neon. Well, the same thing happens if we back up to the previous row. Oxygen, which is going to gain 2 electrons, it's missing the minus sign here. It's missing the minus sign here. So here is oxygen's electron configuration, and then here's what happens after it gains 2 electrons, again missing the negative sign. These 2p4 becomes 2p6 by these 2 electrons, which is the same as neon's electron configuration. Fluorine, same way, gains 1 electron, becomes fluorine minus 1. Here's fluorine's electron configuration, gains an electron, now it's like neon. Okay, so here are the representative elements and what their electron configurations look like. So we back up for these metals to the previous noble gas, and for these we go forward to the next noble gas. If you look on the periodic table, you see these are not in the same row. They are on different rows. These 2 are on one row, and these are on the previous row. Okay, so there is one caveat we have to worry about here, one thing to worry about, to pay attention to. Metals only lose if there's something to gain. You can't just have metals losing electrons in normal chemical reactions. So nonmetals have to be there to gain electrons. So for example, sodium has 1 electron to lose. Chlorine needs 1 electron to fulfill its octet. So the sodium will give 1 electron to chlorine. So the 3s1 electron from the sodium fills the 3p level of chlorine. So bottom line, important thing here is no element will ever gain or lose on its own when we're talking about chemical reactions. There always has to be something to pick up an electron that something else wants to lose, and vice versa. Okay, we will look at some examples going forward here.